As I record this, there is a hurricane about 65 miles off the southern tip of the island of Hawaii. Its name is Lala. Maximum sustained winds 75 miles an hour, which makes it a Category 1. It is crawling northwest at 8 miles an hour, and the National Hurricane Center has the eyewall moving over or near the island's southern end. The Big Island has not experienced a direct hurricane landfall in 155 years. Governor Josh Green declared a state of emergency on Thursday. About 180 Hawaii National Guard members are activated and positioned across the state. High water vehicles are staged in every county. A hurricane warning covers Hawaii Island. Tropical storm warnings cover Maui, Lanai, Molokai, Kahoolawe, Oahu, Kauai and Niihau. Tropical storm force winds extend 220 miles from the center. Now hold that against the other ocean. We are in the middle of what is supposed to be the busiest stretch of the Atlantic hurricane season, and the Atlantic has produced 3 named storms all year. The third of them, Cristobal, formed on Wednesday, and it did not form where anybody was looking. Everyone was watching a tropical wave heading toward the Caribbean. Cristobal instead spun up about 1,000 miles northeast of Bermuda out of a non-tropical gale center that gradually acquired tropical characteristics. It reached 45 miles an hour, moved east at 25, threatened no land whatsoever, and was forecast to be finished within about a day. So here are 2 oceans at the same moment. One cannot organize a storm to save itself and hands its name to a system going the wrong way. The other is putting a hurricane onto an island that has not taken one in a century and a half. That is not a coincidence, and the reason is a single word that explains both. But the question I actually want to answer today is narrower and more useful, and it is this. When that storm reaches the Big Island, what is going to hurt people? Because it is not what most of the coverage is leading with, and the answer has less to do with meteorology than with what that island is physically made of. No guessing, no dramatizing, just the numbers, the mechanism, and the stakes. Before we go on, if you are in Hawaii, tell me in the comments where you are and whether you have power. If you are on the Big Island, I hope you moved early. Subscribe if you want the plain version of these, and a thumbs up helps this reach people who need it. Now, let us get into it. Lala started as an area of disturbed weather in the Central Pacific, the kind of thing forecasters label with an invest number while they decide whether it is going anywhere. It was over 1,000 miles east-southeast of the islands and nearly stationary. It became Tropical Storm Lala on Thursday. At that point, it was about 555 miles east-southeast of Hawaii with maximum sustained winds of 60 miles an hour moving west. The Hurricane Center issued a hurricane warning for the Big Island the same day, which is early and deliberately so. By Friday, Governor Green was telling a briefing with state, county, and federal officials that this was a serious moment and warning that Lala posed a particular threat to Hawaii Island. By Saturday morning local time, Lala was about 90 miles southeast of South Point with winds up to 70 miles an hour. By later that day, it had reached 75 and was formally a hurricane, sitting roughly 120 miles south of Hilo. A tropical storm force gust of 50 miles an hour was recorded near Kealakomo around 10 in the morning. The forecast track takes the center near or just south of the island's southern tip, then south of the smaller islands on Sunday. And I want to flag one detail in that sentence because it is the difference between a near miss and a direct hit, and almost nobody reads it correctly. Lala's strongest winds are on the north side of the eye. Which is the side facing the island? Fox Weather's hurricane specialist, Brian Norcross, put it plainly. Whether or not the center officially makes landfall on the Big Island or passes just to the south, Hawaii Island will take a hard hit. Tropical cyclones are not symmetrical. the storm's own forward motion adds to the wind speed on one side of the circulation and subtracts from it on the other. In the northern hemisphere, with a storm moving roughly westward, that puts the stronger half on the north. So a center passing offshore to the south still drags its worst winds directly across land. Landfall is a technical term about where a center crosses a coastline. It is not a description of who gets hit. Right. Now the other ocean, because the contrast is the key to everything. The 2026 Atlantic season has been, in CNN's phrase, historically quiet. Arthur affected the U.S. Gulf Coast in mid-June. Bertha came and went in late July. Then nothing at all until Cristobal on the 12th of August. A normal Atlantic season has at least 3 named storms by the 3rd of August and 4 by the 15th. It is also behind on hurricanes. The first hurricane of a typical season forms around the 11th of August, and this year there has not been one. NOAA raised its odds of a below-average season from 55% to 75%, and dropped its projected range of major hurricanes, Category 3 or greater, from 1 to 3 all the way down to 0 to 2. If 2026 finishes without a major hurricane, it will be the first season since 2013 to do so. And the reason forecasters give is not mysterious. It is El Nino, producing what has been described as record-strong wind shear across the Atlantic. So let me explain that properly, because it is the single mechanism that ties both halves of this video together. El Nino is a periodic warming of the sea surface in the central and eastern equatorial Pacific. In its neutral state, trade winds blow east to west along the equator, piling warm water up in the western Pacific and allowing cooler water to well up in the east. During El Nino, those trade winds weaken or reverse. The warm pool sloshes eastward and the whole atmospheric circulation over the tropical Pacific reorganizes. That reorganization does not stay in the Pacific. Rising air over the newly warmed Central Pacific has to come down somewhere, and a great deal of it descends over the tropical Atlantic. Sinking air suppresses the thunderstorm activity that tropical waves need. It also alters the upper-level winds, strengthening westerly flow high above the Atlantic, while the low-level trades keep blowing east to west. The difference between winds at the top and the bottom is wind shear, and shear is what kills a developing tropical cyclone. A tropical storm needs to build a vertical column, a stack of thunderstorms wrapped around a center, aligned from the sea surface to the top of the troposphere, so that the heat released by condensation up high sits directly above the circulation down low and reinforces it. Shear tilts that column over and pulls the top away from the bottom. The heat engine gets disconnected from its own exhaust and the system falls apart. That is what has been happening in the Atlantic all summer. Warm water, plenty of moisture, waves coming off Africa on schedule, and an atmosphere that shreds them. There is a second Atlantic inhibitor worth knowing because it is visible from the ground. The Saharan air layer is a mass of hot, extremely dry, dust-laden air lifted off the Sahara and carried westward across the Atlantic by the trades. It peaks from late June into mid-August. When it is active, you can see it on satellite as a brown haze streaming off Africa, and people across the Caribbean see it as a pale, milky sky instead of a blue one. It suppresses storms in 2 ways. The dry air starves developing thunderstorms of the moisture they need, and the layer carries its own embedded wind maximum, adding still more shear. If the sky where you are looks washed out and the air feels thick, That is what it is. And for anyone with asthma or another respiratory condition, that dust is a genuine health issue in its own right, worth staying indoors on the worst days and worth keeping windows shut. Now flip to the Pacific, because El Nino does the mirror image there. The same reorganization that increases shear over the Atlantic decreases it over the Central Pacific, and simultaneously warms the sea surface along the equator and toward Hawaii. Warmer water, weaker shear. Both of the things that were killing Atlantic storms are removed at once. So during El Nino years, the Central Pacific tends to be more active, and Hawaii, which sits in a basin that in an ordinary year produces only about 4 or 5 tropical cyclones, gets more traffic. And that explains something about Hawaii's history that surprises people. The islands are surrounded by ocean in the deep tropics, and yet they are hit remarkably rarely. The reason is that storms approaching from the east normally run into a wall of hostile conditions before they arrive. Cooler water north of the main development region and strong shear. You can watch that happen. Hurricane Fausto, the first hurricane of this year's Eastern Pacific season, reached Category 2 in mid-July and tracked west toward Hawaii. And then high shear, dry air, and cooler water took it apart. By the 29th of July, it had degenerated to a remnant low with 35-mile-an-hour winds as it passed 285 miles north of Hilo. The insurance broker Aon recorded negligible damage. That is the normal outcome. That is what usually happens to storms aimed at Hawaii. Lala is not doing that. Lala is strengthening on approach. The most recent damaging tropical cyclone to affect the islands was Hurricane Hone, a Category 1 that passed about 50 miles south of South Point on the 25th of August, 2024. Lala is on a closer track, and Yale Climate Connections notes it could become the first hurricane on record to strike the Big Island. Before I answer the question I posed at the start, I want to give you 2 pieces of background because the answer depends on both. The first is why Hawaii is there at all, and it is not the usual reason islands exist. Almost every volcanic island chain on Earth sits along a plate boundary, an arc of volcanoes above a subduction zone like Japan or the Aleutians. Hawaii does not. It is in the middle of the Pacific Plate, thousands of kilometers from the nearest boundary. What is underneath it is a hot spot, a persistent plume of anomalously hot rock rising from deep in the mantle, roughly fixed in place while the plate slides over the top of it at around 8 to 10 centimeters a year. The plume melts the base of the plate, magma rises, and a volcano is built. Then the plate carries that volcano away northwestward, the magma supply is cut off, and a new one starts building over the stationary plume. Do that for tens of millions of years, and you get a conveyor belt of islands, oldest at the far end, youngest at the hot spot. That is the Hawaiian chain. Kauai is about 5 million years old. The Big Island is under 1 million and is still being built. Its youngest lava flows are days old in places, which means the island in Lala's path is, in geological terms, an infant. And that matters enormously for what happens next, because young volcanic terrain has not had time to become anything a slope engineer would recognize as stable ground. The second piece of background is rainfall, and Hawaii holds a record here that almost nobody knows about. The islands are among the wettest places on the planet. Mount Waialeale on Kauai averages something on the order of 30 to 40 feet of rain in a year, measured in feet, not inches, and is routinely listed among the wettest spots on Earth. Hilo, on the Big Island's windward side, is consistently the wettest city in the United States. None of that is because more moisture arrives here than elsewhere in the tropics. It is because of what the terrain does to the moisture that arrives. The process is called orographic enhancement, and it works like this. When moist air is forced to rise, it cools because the pressure drops with altitude and the air expands. Cooler air holds less water vapor, so the vapor condenses out into cloud and rain. And if the air keeps being forced upward, it keeps condensing. Force enough moist air up a big enough mountain for long enough, and you can wring out a genuinely extraordinary quantity of water. That is the entire explanation for Waialeale and for Hilo, and for the fact that the wet and dry sides of a Hawaiian island can differ by a factor of 10 in annual rainfall over a distance you could drive in an hour. Now scale that process up. A hurricane approaching the Big Island is pushing deep tropical moisture against terrain that rises from sea level to nearly 14,000 feet. Mauna Loa and Mauna Kea are not hills. Measured from their base on the seafloor, they are among the largest mountains on the planet. Air cannot get around them quickly enough, so it goes up. And it rains itself out on the way, which is exactly the process about to be applied at hurricane scale to a mountain. And there is one more thing about this island worth knowing before we go on, because it tells you what its slopes are capable of. On the 2nd of April, 1868, a magnitude 7.9 earthquake struck the Big Island, still the largest in Hawaii's recorded history. It was followed by intense rainfall. And on the flank of Mauna Loa, above a place called Wood Valley in the Kau district, a mass of saturated ground gave way and ran down slope. It moved fast enough that nobody outran it. 31 people were killed. That was not a hurricane, but it was the same fundamental arrangement: water in young volcanic ground on a steep slope above people. The trigger was different. The material was identical. So we have a storm doing something rare on an island that has not seen this in 155 years. Which brings me back to the question I asked at the start. What is actually going to hurt people? It is not the wind. It is the water, and it is the ground it lands on. Start with the Hurricane Center's own language, because they are not being subtle. Their warning is of life-threatening flooding and mudslides, especially in steep terrain. Now look at the rainfall numbers. More than a foot of rain across much of the Big Island. Isolated amounts over 2 feet. Yale Climate Connections cites forecasts of 16 to 20 inches, locally over 24. Up to a foot on parts of Maui. 2 feet of rain is an extraordinary quantity, and you now know exactly why it is possible here. Orographic enhancement, running for 2 days, driven by a hurricane instead of a trade wind. And now the part that makes this a geology story rather than a weather story. Consider what that water is landing on. The Big Island is 5 volcanoes. It is the youngest land in the Hawaiian chain, and, in geological terms, it is brand new. Built from basalt lava flows, volcanic ash, and loose fragmental material, some of it laid down within living memory. Soils on young volcanic terrain are thin. Slopes are steep because lava piles up at its angle of repose and has not had time to be worn down. Layered volcanic ground also does something specific with water. Basalt flows are often highly permeable, so water sinks in fast, until it reaches a less permeable layer beneath, an old soil horizon or a dense flow interior. At that boundary, the water stops going down and starts moving sideways, building pressure along a plane that is already parallel to the hillside. Raise the water pressure in that plane enough, and you reduce the friction holding the material above it in place. The slope fails. That is what mudslides in steep terrain means on a volcanic island. A specific mechanism with a specific trigger, and the trigger is sustained heavy rainfall on saturated ground. There is a second-order effect, and CNN flagged it. Rain-soaked soil makes trees easier to topple. Wind a dry-rooted tree would survive brings it down when the root plate is sitting in mud. That is how you get downed power lines from a storm whose winds were survivable on paper. And the utility pole was already down over Mamalahoa Highway near Ocean View. Note, too, where the strongest winds are going. Norcross pointed out that Lala's worst winds would be lashing volcanic slopes thousands of feet above sea level, with gusts at higher elevations potentially topping 100 miles an hour. Elevation increases exposure, less friction from surrounding terrain, and wind accelerates over a ridge. So the picture is the heaviest rain on the steepest, youngest, least consolidated ground, the strongest winds on the high slopes, and the storm's forward motion putting its worst quadrant over land, whether or not the center technically arrives. The southern end of the island, the part in the eyewall's path, is remote and rural, coffee and cattle country. State Representative Janae Capella urged residents to stay alert. And that area's population has been growing precisely because it is affordable. So, practically, and this is for the next 48 hours, if you are on the Big Island, the rain is the thing. Do not be reassured by a Category 1 wind number. 12 to 25 inches on steep ground is the life-threatening part, and the Hurricane Center said so explicitly. Get out of the bottom of gulches and off the base of slopes. Volcanic terrain funnels water into steep-sided channels fast. Do not drive through flowing water. It is the single most common way people die in tropical systems. Expect the power to go out and plan for days rather than hours. And on the coast, surge up to 3 feet on the eastern side around high tide. Waves 8 to 12 feet on east-facing shores. Offshore seas as high as 20 feet. Stay off the water through Sunday. The Hawaiian Islands exist because a plume of hot rock has been building volcanoes on a slowly moving plate for tens of millions of years. Every island in the chain is a volcano that was once where the Big Island is now, and each has been eroding since the day it drifted off the hotspot. Rain is the tool that does most of that erosion. The valleys of Kauai and Molokai, the ones people cross the Pacific to look at, were carved by exactly the process that will run on Hawaii Island over the next 2 days, repeated across a few million years. What is arriving tonight is not an interruption of that. It is a normal installment of it, delivered fast, onto slopes that happen to have people living on them. Tell me in the comments where you are and whether you still have power. Subscribe if you want the follow-up once the damage assessments come in. And thank you for giving me this much of your afternoon. I will see you next time.